स्टूडेंट्स, कुछ लाइन कोडिंग की टेक्निक्स की हम लोग बात कर रहे हैं और हम लोगों ने कुछ क्लासिफिकेशंस, कुछ कैटेगरीज ऑफ दीज लाइन कोडिंग स्कीम्स दैट वी डिवाइड देम इनटू. वी डिस्कस दोज and we started the discussion of each one of those schemes. Let's go back to the slide and carry on with that discussion. Students, once again, 5 distinct categories. We discussed unipolar NRZ. We also spoke about the polar NRZ, and we saw that there are 2 different variants, NRZ-L and NRZ-I. हम लोगों ने NRZ-L और I दोनों को डिस्कस किया था और ये देखा था कि in the first case, NRZ-L, the difference in level, that represents a 0 or a 1 bit. In NRZ-I, the inversion or the non-inversion represents what the next bit is going to be. Now, students, in this particular case, the normal problem that we face is that if there is a problem with the synchronization between the sender and the receiver, and the clocks are not synchronized in this NRZ-L or I case, then we will have problem discerning or interpreting zeros and ones at the receiving end. Also, if we receive a long sequence of zeros or ones, for example, in NRZ-L, NRZ level, the average signal power, it can become skewed. And therefore, once again, the receiver will have difficulty interpreting the bit value. Students, another disadvantage is that the value of the power density is very high around the frequencies that are close to 0. And when that happens, we say that the signal contains a DC component, which is bad for receiver once again to retrieve the signal. Students, once again, the main problem with NRZ encoding was the sender and the receiving clocks, when they are not synchronized, the receiver does not know where the 1 bit has ended and where the next bit is starting. So, a solution is the return to 0 scheme. Students, in the return to 0 scheme, it uses 3 values instead of 2 values. It uses 3 voltage levels instead of 2 voltage levels. So you can see that we have got a negative, we have got a 0, and then we have got a positive. So for every single bit, we are using 3 voltage levels in this particular case instead of 2 voltage levels, as was the case with NRZ-L. Now, this case, students, we have got a 0, which is represented by a voltage level starting from the negative end. As you can see, it changes its value in the middle of the bit. The transition happens to 0, and then it finishes right here. Now the next bit is 1, students. So this signal will go up and it will start from the positive level. So you'll see that the start of the bit 1 is at the positive level. Transition happens in the middle of the bit and it finishes right here. Next bit is 0 again. 0 mein, we are going to start at the negative voltage level. So we'll come down and we will change states in the middle. We'll finish right here. The next bit is again 0. So we come down to the negative voltage level. We start from here, make a transition and finish here. The next bit is 1. We go up, start from the positive level, make a transition in the middle, and we finish here. So students, we are essentially using 3 different voltage levels as compared to the NRZ techniques. Students, the main disadvantage that we have of this encoding is that it requires 2 signal changes to encode 1 bit. So we are changing, we are having 2 changes in the signal to represent 1 bit, and this essentially means that we are occupying greater bandwidth as compared to the non-return to 0 techniques. Now students, there is another issue with this return to 0 scheme, and that is the RZ scheme. Because it uses 3 level of voltages, it is more complex to create and interpret at the receiving end. So students, because of these 2 problems, this is mostly replaced by Manchester and differential Manchester that we'll discuss next.